Hello students, in this video we are going to see some applications of trigonometry. Before going into this chapter, you have to see my previous videos which I posted on Introduction to Trigonometry. I have given two videos. Please go through that. Please see the videos because after seeing that only if you watch this, you'll get a clear idea about trigonometry. In that video, I have explained the basic ratios and basic identities, and using that, I did many problems. So go through that. I'll give the link in the description box. And come to this chapter. In this chapter, based on the trigonometric ratios, we are going to see some applications of trigonometry. The major part what we are going to see is heights and the distances. We are going to do some problems for finding the heights and distances. Before that, you should know what is the angle of elevation and angle of depression. Angle of elevation, what it is. If I am the observer, I am standing at the ground level or at the horizontal level. Here the observer is standing and the object is somewhere there. He has to see upwards. At the horizontal level, if the line of sight is like this, means this is the angle of elevation. I repeat, the observer is standing at the below, he is here, and the object is up from his line of sight. Okay, so the angle of elevation is the angle which the horizontal line makes with the line of sight. This is called angle of elevation. Come to the angle of depression. The observer is at the top of a building or he is at a height. Okay, the object is below his eyesight. So here the horizontal line, this is his where he is standing, and this is the line of sight since the object is there in below the observer, and the angle which the horizontal line and the line of sight makes, no, that is called angle of depression. Angle of depression means below that he is seeing the object. This is above he is seeing the object. This is angle of elevation and this is angle of depression. This is the first problem. A tower stands vertically on the ground. From a point on the ground which is 15 meters away from the foot of the tower, the angle of elevation of the tower, of the top of the tower is found to be 60 degrees. Find the height of the tower. A tower stands vertically. So we have a tower which is standing vertically. So first we have to draw the diagram. In some problems they will give the diagram. In some problems we have to draw the diagram based on the given data. We have a tower which is vertical. Okay, so we have a tower which is vertical on the ground. From a point on the ground which is 15 meters away from the foot of the tower. This is the foot of the tower. From this we have to take a point which is 15 meters away. So from the foot of the tower, I am taking a point. The distance between these 2 points is 15 meters. From this, the angle of elevation. Already we saw the angle of elevation is nothing but the angle which the horizontal and the line of sight makes. That is called the angle of elevation. Isn't it? So here the angle of elevation is given as 60. So this horizontal line, and from there the observer is seeing the height, right? So this angle is given as 60 degrees. Am I right? And what we have to find? We have to find the height of the tower. This only we have to find. We know all the trigonometric formulae, no? Can you tell me what is sine theta? Sine theta is equal to opposite side by hypotenuse, and cos theta is equal to adjacent side by hypotenuse, and tan theta is equal to opposite side by adjacent side. These are the trigonometric ratios which we saw in the previous video. Am I right? So you should know which one is applicable to this problem. This only we have to find, and the opposite angle is given, right? So we know the side which is adjacent to the angle. Hypotenuse we don't know. So opposite side and adjacent, involving this, whichever formula is applicable, we have to make use of that. So here hypotenuse we don't know, so we are not able to take this. Here also hypotenuse we don't know. Tan theta is equal to opposite side by adjacent side. So we have to use this formula for finding the height of the tower. So here theta is given as 60 degrees. Okay. So tan theta, that is tan 60, equal to opposite side we don't know, let it be x. So x by 15. What is the value of tan 60? What is the value of tan 60? Tan 60 is equal to root 3. First you have to memorize all these values from 0 to 90. We have a table. No, you have to keep all the values in your memory, because in problems like this we have to use those values. So first study that. So tan 60 is equal to root 3. So here root 3 is equal to x by 15, which implies x is equal to 15 into root 3. Is it clear? Therefore, x is equal to 15 into root 3 meter. In some problems, in the problem itself, they'll give the root values. If it here we have root 3, no. In the problem itself, they will give the square root of 3 value. If it is given, means we have to multiply, or else no need. Just as it is, what we are getting, no, 15 into root 3, that we can give as the final answer. If the value is given, for example, if they have given in the problem, if they have given root 3 is equal to 1.73, we have to take this value and we have to multiply that with this 15. But here in the problem, they didn't give root 3 is equal to 1.73. So as it is, what we are getting, 15 into root 3, we can take that. Okay. And I have explained in one video how to find the square root of a integer value, that is perfect square, and square root of real numbers. If you want to know how to find square root of 3, go through that video. That link also I will give in the description box. So go through that and have a clear idea how to find square root of a number. Now the second problem. On seeing the problem, you may have a fear that this is a very lengthy problem, but it is not the case. The problem they have given in a very big manner, but when we convert everything to equation, it is very easy. Using trigonometric identities, we can find it very easily, but the problem looks like a big one. Okay, now come to the problem. An electrician has to repair an electric fault on a pole of height 5 meter. He needs to reach a point 1.3 meter below the top of the pole to undertake the repair work. See the figure they have mentioned, so they have given the figure too. In some problems they will give the figure. If the figure is not given, means we people have to draw the figure, what we did in the previous problem. Okay, but here the work is easy since the figure is given. What should be the length of the ladder that he should use, which when climbed at an angle 60 degrees, the angle is given to the horizontal, would enable him to reach the required position. Also, how far from the foot of the pole should he place the foot of the ladder? They have given root 3 is equal to 1.73. So when we get in the answer root 3 means finally we have to multiply this value and we have to finally give the answer. Okay, so now come to the figure. This is the figure what they have given. Okay, what is given? An electrician has to repair an electric fault on the pole of height 5 meter. This is the pole. The height of this pole is 5 meter. Okay, and he needs to reach a point 1.3 meter below the top of the pole. So he has to reach the point B, which is 1.3 meter below. So this is 1.3 meter. From the top of the pole below 1.3 meter, he has to reach a point. So what is this distance? This distance is equal to 5 minus 1.3. So in between distance, which is equal to 3.7 meter. This distance BD is equal to 3.7 meter. This BD. So the total distance is 5 meter, and from the top he has to reach a point below, which is 1.3 meter below. So in between distance BD is equal to 5 minus 1.3, which is 3.7 meter. He has to repair. What should be the length of the ladder? This is the ladder what we have placed BC. We are going to find what is the length BC. Okay, so for that we are going to find BC. What is BC? Okay, then they have given the angle of elevation, that is with the horizontal. What is the angle? So this angle is given, 60 degrees is given. And anything else? How far from the foot of the pole should he place the ladder? So this distance also we have to calculate. DC also we have to calculate. So in this problem we are going to find two things. One is BC, the other one is DC. We know this angle and this opposite side. Opposite side is known. Hypotenuse we don't know, and this DC also we don't know. Okay, so first we are going to find what is BD. What we are going to find? We will start from here. Okay, I am going to find what is BC. So first one we are going to find BC. So what is BC actually? BC is the hypotenuse. We know the opposite side. So the trigonometric ratio which involves opposite side and hypotenuse is sine theta is equal to opposite side by hypotenuse. So here theta is 60 degrees. Sine 60 is equal to opposite side. Now only we have calculated, that is 3.7. 3.7 by hypotenuse we don't know. Let it be x. So 3.7 into x. What is sine 60 value? Sine 60 is equal to root 3 by 2. What is sine 60? Sine 60 is equal to root 3 by 2. So root 3 by 2 equal to 3.7 by x. Take this x to the other side. So x is equal to 3.7 into 2 by root 3, which is equal to 3.7 into 2 by root 3. In the problem itself they have given the value as 1.73. We have to multiply and we have to write the final answer. After multiplication, after simplification, everything, no, we are getting the answer as 4.28 meters approximately. This is the approximation. Okay, this you can multiply and simplify, no? Okay, now come to the second one. This one already we got. This BC is x value we got as 4.28. Now we are going to find what is DC. DC means the adjacent side. So tell me the ratio which involves adjacent side and the hypotenuse. So it is cos. Not cos we are going to use, since if we use cos, no, we have to involve this side with this side. This now only we got the answer is 4.28. Since it is in decimal, I am not going to take that. See, already we know the opposite side by adjacent side, that is tan. This we are going to take. We can use this also, but since it is already an approximate value, when we take that again to a calculation, again we have to get a tedious calculation. For avoiding that, I'm not going to take that. Opposite by adjacent, that is tan, we are going to use. Okay. So tan theta formula is opposite side by adjacent side. Here theta is 60. So tan 60 is equal to BD by DC. What is the value of tan 60? Tan 60 is equal to root 3. What is tan 60? Tan 60 is equal to root 3. So root 3 is equal to BD. We have calculated. What is BD we did? BD is equal to 3.7. 3.7 by DC only we are going to calculate, let it be y. Because previously we took the unknown as x. Now here I am taking that as y. So on multiplying, cross multiplication, y is equal to 3.7 by root 3, which is 3.7 by, what is root 3 given? 1.73. What is that given? 1.73, and after simplification we are getting this answer as 2.14 meter approximately. So this is the distance where we have to place the ladder. Is it clear? Now come to the third problem. An observer 1.5 meter tall is 28.5 meter away from a chimney. The angle of elevation of the top of the chimney from her eyes is 45 degrees. What is the height of the chimney? Already the observer is having a height 1.5 meter and he is standing 28.5 meter away from the chimney, and the angle of elevation is given as 45 degrees. We are going to find the height of the chimney. Here the diagram is not given, so we have to draw the diagram. If I take this as the chimney, right, an observer is standing at a distance 28.5 meter away from the chimney, and that observer is also having a height 1.5. He is of height 1.5 and this chimney's height is not known, and for the observer we will connect these two lines because from this point only we have to take the angle of elevation, because here only he will see the height of the chimney. So from that we have to draw the line of sight, and this angle of elevation is given as 45 degrees. So the angle of elevation is 45. If I take the height, topmost point of the chimney as A, and this as B, and this as C, the topmost point, the observer from his line of sight, he is seeing with an angle 45 degrees. That is the angle of elevation. What we are going to find? We are going to find what is the height of the chimney, that is the distance AB. If I take the distance AB, if I take this as E, the distance AB can be written as AE plus EB. EB is nothing but, if I take this point as D, EB is equal to DC. What is DC given? 1.5. So AE plus DC, which is equal to AE plus, what is DC given? 1.5. This 1.5 has to be added after the calculation of AE. This length is given, no, CD is given, CD and DE both are same, so I can take this as 28.5. The angle is given, the adjacent side is given, we are going to find the opposite side, this one. Tell me the relation which connects opposite side by adjacent. It is tan. Tan theta is equal to opposite side by adjacent. Here the theta value is 45 degrees. Tan 45 is equal to AE is the opposite side by DE is the adjacent side, which is 28.5. And for tan 45 is 1. So 1 is equal to AE by 28.5. So what is AE? AE is equal to 28.5. AE is equal to, we have to multiply this. AE is equal to 28.5. So this is 28.5. What we have to calculate? We have to calculate what is AB. AB is equal to AE plus EB, that is AE plus 1.5. Now only we calculated AE as 28.5 plus 1.5. What is the final answer? 30. So the height of the chimney we got is 30 meters. Is that clear? The next problem, from a point P on the ground, the angle of elevation of the top of a 10-meter tall building is 30 degrees. A flag is hoisted at the top of the building and the angle of elevation of the top of the flag's top. That is, at the building we are placing the flag. No, therefore that we will use a stick. No, that is the height of that is flag's top. Okay, so this is the building and at the top we are placing the flag with using a stick or pole. This height is the flag's top height. And for that we have the angle of elevation as 45 degrees. We are going to find the length of the flag's top and the distance of the building from the point P, and for that they have given the root 3 value as 1.732. In the previous problem they have given only 2 decimals. Here they have given 3 decimals. That is not a problem. Actually root 3 is equal to 1.732. Whatever value they are giving, we have to make use. If the value is not giving means final answer, just we can take root 3 alone. No need to multiply and simplify. Okay. Here the diagram is not given. So first we have to draw the diagram. Then we have to go for the solution. Okay. So what is given? From a point P on the ground, the angle of elevation of the top of a tall building. So we are taking a tall building. The height of the building is also given. What is that? 10 meter. Okay. So we are seeing the top of the building, that is at a point P. And the elevation on seeing the top of the building is also given. What it is? The angle of elevation? 30 degrees. So when I see the top of the building, the angle of elevation is 30 degrees. Am I right? At the top of the building, we are going to hoist the flag. And this is the flag's top. Okay. This is the top where we are going to hoist the flag. Okay. And for this, they have given the angle of elevation as 45 degrees. So when the observer see the top here, the angle of elevation is given as 45 degrees. Okay. We are going to find the length of this portion alone. This one. What it is first, and the distance of the building from P. This is also we are going to find. I have given labels as this is the point P, this is given A, B, D. So we are going to find what are the things we are going to find. B, D is equal to what, and P, A is equal to what. These two only we are going to find making use of this thing and the given angles. Okay. So first I'm going to consider the right angle triangle PAB, the smaller triangle, using the degree 30. No, this triangle I'm going to use. 30 degrees is given, the opposite side is given. I don't know the adjacent side. So what is the formula? Tan. So tan of angle here is 30. Tan 30 is equal to opposite side is 10 meter by adjacent side is PA. We don't know. Okay. What is tan 30 value? 1 by root 3. 1 by root 3 is equal to 10 by PA, which will give PA I'm taking to the other side. So PA is equal to 10 root 3. So we got PA is equal to 10 root 3. Finally, we will multiply root 3 as 1.732. So we got the adjacent side as 10 root 3. Okay, this one we know. Now we are going to find this distance alone. For that, if I take the unknown distance as x, combining these two together, the whole distance is 10 plus x. So now this is the opposite side. Adjacent side already we got. The whole angle is 45 degrees. Which formula I can apply? The tan formula. What is the formula we have for this angle? Tan of 45 degrees is equal to opposite side by adjacent. Adjacent now only we got as 10 root 3. This is 10 root 3. Opposite side, this portion is not known x. This portion alone we know. So it is 10 plus x. What is tan 45? It is 1. 1 is equal to 10 plus x by 10 root 3. So which implies I multiply this. 10 plus x is equal to, when we multiply this is 10 root 3. X alone we need. So x is equal to 10 root 3 minus 10. Am I right? Which is equal to 10 is common. Root 3 minus 1. What is the value of root 3 given? 1.732 minus 1, which is equal to 10 into 0.732, which is equal to 7.32 meters. So this is the height of the flag hoist. Okay, flagstaff is at the height 7.3 meter, and the building is at the distance. The building is at the distance 10 root 3. So it is PA is equal to 10 root 3 is equal to 10 into 1.732, which is equal to 17.32 meters. So these are the answers. First answer and this is the second answer. Is it clear?